Hello, children. Welcome to Rai Tuition Classes. We are starting with the geometry revision series of 2 mark questions. This is the first lecture of it. Okay. Now here, let's start. Okay. Question number 1. In the adjoining figure, that is, we are looking at this figure. Okay. BC is perpendicular to. Can you see this BC? This is BC perpendicular to AB. BC is perpendicular to AB. BC is perpendicular to AB. But it makes an angle of 90 degree. Then AD perpendicular AB. Can you see this AD perpendicular AB? AD perpendicular AB. AD make perpendicular to AB. That means this angle is 90 degree. Angle between them is 90 degree. BC is 4. You can see the length of BC is 4. And they're giving us length of AD as 8. Okay. And they want me to find area of triangle ABC upon area of triangle ADB. They want me to find area of triangle ABC upon area of triangle ADB. They want me to find area of triangle ABC upon area of triangle ADB. Look at the two triangles, children. Don't you realize, okay, for triangle ABC, BC is the height, AB is the base. For triangle ADB, AB is the base, AD is the height. That means both these triangles have a same base. They have a same base, okay? So triangles, I can write triangle ABC. I'll just mention like this. Triangle ABC and triangle ADB have same base BC, have same base BC, okay? Now listen, you learn one property, okay? The areas of the triangles having same base, equal base, are proportional to the corresponding heights. Areas of the triangles having same base are proportional to the corresponding heights. That means ratio of the areas of the triangles having equal base is equal to ratio of the corresponding heights. That means area of triangle ABC upon area of triangle ADB is equal to, correct, ratio of the areas of the triangles having equal base is equal to ratio of the corresponding heights. ABC का height क्या है? BC. और triangle ADB का height क्या है बेटा? AD. So BC upon AD. But you have to write the reasons. Areas of the triangles, areas of triangles having equal base, equal base are proportional to corresponding heights, are proportional to corresponding heights, are proportional to corresponding heights. Are you getting me, children? So I hope people understood this. Now, area of triangle ABC upon area of triangle ADB. I rewrite, I want this ADB is equal to ratio of the heights. Please have a look here. BC is given as 4, AD is given as 8. You can see here, since BC is given as what? BC equal 4 and AD equal 8. And that is the reason why did you substitute these values here? 4 one time, 4 two times. So what is the answer you get? Area of triangle ABC upon area of triangle ADB is equal to, how much you get, children? 1 upon 2. This is the answer, okay, of this question number 1. We move on to question number 2, children. Basically, look at this question. In the adjoining figure, ABCD is a cyclic quadrilateral. D dash, C dash, E. And you have to prove this angle BC, red angle, is congruent to angle BAD, blue angle. The red angle is congruent to angle blue angle, BAD. BCE congruent to BAD. Basically, this is a theorem, children. Exterior angle of a cyclic quadrilateral is congruent to its interior opposite angle. Prove that. Exterior angle of a cyclic quadrilateral is congruent to its interior opposite angle. Prove that. Exterior angle of a cyclic quadrilateral is congruent to its interior opposite angle. So extra angle is given. ABCD is a cyclic quadrilateral. BC is the exterior angle. You have to prove that BC congruent BAD. Okay, children? So simple. Just have a look at BC, children. With what property you can relate it in this proof? Use some property so that this angle BCE gets involved. A linear pair. You can see you can use linear pair. So BCE has got involved. Okay, BCE plus angle BCE. You want BCE first, right? I'll think of writing BC only. angle BCE plus angle BAD is equal to 180 degrees. What is the reason? BCD I want, okay? Angle BCD plus angle BCD, children. Again, I'm so sorry. It should be BCD, okay? Angle angle BCE plus angle BCD is equal to 180 degrees. Angles in a linear pair. Call it as statement number one. Angles in a linear pair. Angles in a linear pair. Angles in a linear pair. Children, now you can see here your BC got involved. Okay, BC plus BCD equal 180. Now I want to involve BAD. BAD को भी एक प्रॉपर्टी में इन्वॉल्व कर सकता हूँ क्योंकि ये साइक्लिक क्वाड्रिलेटरल है साइक्लिक क्वाड्रिलेटरल में ऑपोजिट एंगल्स आर सप्लीमेंट्री तो आई विल राइट क्वाड्रिलेटरल ABCD is a cyclic quadrilateral okay then only I can use its property it's given to us so now I'm going to use a property therefore angle BAD you want, okay? BAD plus BCD is equal to 180 degree. BAD plus angle BCD equal 180 degree, okay? This is your statement number 2. You can write opposite angles of cyclic quadrilateral. Opposite angles of cyclic quadrilateral are supplementary. Opposite angles of opposite angles of cyclic quadrilateral are supplementary. Supplementary. Okay. Now you can see here, children. Now, I want BC and BAD in one line. I want to show they are congruent, okay? So, whereas BC is present in first statement, BAD is present in second statement. Just think, don't you agree the right-hand side 180 है इसका भी right-hand side 180 है. When the right-hand sides are same, I can say the left-hand sides are equal. Therefore, BCE plus angle BCD is equal to BAD plus angle BCD. Can I say from 1 and 2? Can I say from 1 and 2? The right hand side is same, children. Right hand side is same. Okay. Then you can see, children, BCD gets cancelled. So what you are left with, angle BCE, congruent angle BAD. A very simple sum, children. You can see this. There was shortage of space, children. I had to rub off that question number 1 and question number 2 already solved. Okay. Now question number 3, children. If sine theta equals 7 upon, what is given? Sine theta equals 7 upon 25 is given to us. Okay. And they want me to find cos theta. If sine theta and cos theta, they are related by an identity. They are related by an identity. What is that? Sine square theta plus cos square theta is equal to 1. Sine square theta plus cos square theta equals 1. This is an identity. Now you can substitute in place of sine square theta 7 upon 25 the whole square, okay? Plus cos square theta is equal to 1, okay? So what will happen? Cos square theta equals 1 minus this 7 upon 25, that is 49 upon 625. 7 upon 25 the whole square. Now cos square theta equal, children, what will happen? 625 minus 49, the whole thing upon 625. When you solve it, children, cos square theta equal 576 upon 625. I hope people understand your cross multiplication we did. 1 can be taken as 1 upon 1, then we cross multiply. And this is what I got, okay? Now, cos theta is square root of 576 upon 625. What is square root of 576? 24. What is square root of 625? 25. So what is cos theta equal? 24 upon 25. Very simple and very easy question, children. This is the answer, okay? Now what? Question number 4, children. Actually, let me try to kind of squeeze here. Space is not there. See, what is, find the distance between the points R coordinate 0, 3 and S coordinate 0, pi by 2. Find the distance between the points R coordinate 0 comma minus in S coordinate. So R coordinate is, what is it? 0 comma minus 3. What is S coordinate? S coordinate is 0 comma pi by 2. So what is distance between R and S? Distance between R and S should be, children, x2 minus x1 root of, I'm so sorry, children, it should have been root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So what will happen? Root of, please have a look here. X2 minus x1 is 0 minus 0 the whole square. Y2 minus y1 is 3 upon 2 minus of minus 3 the whole square. So what will happen, children? Root of 0 minus 0 is 0 square, 0 square is 0. So what will happen here? 3 upon 2, 3 upon 2 plus 3 plus 3 the whole square. So what will happen? This root sign goes off, and what you're left with, children, straight away the root sign goes off, and what you're left with, distance between R and S equal, distance between R and S equal, how much you get? You can see it here. This is 6 plus 2, 6, 3 upon 2 plus 3. Square root, nikal gaya. Distance between R and S. So this is distance between R and S equal. People know how to add it, okay? This is 3 upon 1, cross multiply. 2, 3, 1 3s are 3. Plus 2 3s are 6 upon 2. So distance between R and S is equal to 9 upon 2. So distance between R and S equal 4.5 units. 4.5 units. Okay, very simple sum, children. Very easy question. Okay, we move on to the next 4 questions. Got over, children. Got it. We go to the next question now. Yeah, next lecture. Okay.